Jenny,
Yay.
Keith,
Okay,
Hank.
all right. All right. Well, welcome everybody to Tuesdays at 8. If you're watching the replay, reminder that the Tuesdays at 8 is now on the 2nd and 4th Tuesdays of the month. Perfect. Okay. Hi, all. It's noisy here. Okay, Hank, we got you. All right, we're going to start it out with the sunny sun report. So I'm going to go ahead and share. What do we got going on in here?
Surface of the sun.
Surface of the sun.
Go for it, Jenny.
In a second, I'm trying to get to the part I can see the screen better. Oh, okay.
That's a good idea.
Exit full screen so I can see it better. Okay. We've had all kinds of activity. It's been 2 weeks since you've had a sunny report from us. And the sun activity is really heating up as we move closer to the maximum of the solar cycle 25. So we've got a number of slides to show you with kind of an overview of everything that's been happening and a few teasers if you haven't been following it along with us during the weeks. So here we have the current list of the active regions on the sun. This is a HMI intensity gram. I believe this one from Earth Sky. Or yeah, basically it's from the SDO satellite, and so it's a NASA-based one. So you're going to see only about 2, 4, 6, 7 active regions. There've been a lot more than that over the past period, and there's stuff that'll be coming from around the eastern limb, but it hasn't arrived yet. So there's a number of active regions that have departed. And the most active regions that we have seen have been active region 3559, which you see up at the top of the screen in the northeast, and then active regions 3555 and 3561, which are down in the southwest. And those two particular areas have had the largest sunspot regions. And I think at one point today, there were 32 sunspots in 3559, and that dwindled down to 20. So as it has pushed off flares, some of their sunspots have vanished. And down below, 3561's been the one that's heated up the most today. We've seen a lot more flare activity from that.
Wow, that's a lot of sunspots on there.
Yeah, I was surprised when I saw that 3559 had tripled in size over a matter of a couple of days.
You might be able to see it with the solar glasses and binocs.
Well, they're saying that you should be able to see those unless they start to dwindle more, but you got to have the protective eye gear to do it.
Yeah, absolutely. And of course, we have had cloudy days and rain. So our typical sunny weather here. But we do need the rain. So no complaints. And I get to see it here and catch up. All right. Are we on to number 2?
Yep, on to number 2.
Layers that they overlap. Oh my gosh. Okay, let's see.
All right, what you see here is, again, the same flare groups that we mentioned. 3559 actually had 2 pieces that flared at the same time, which is why you're going to see 2 bright blobs next to each other in the northeast. And then at the same time, AR 3561 also erupted down in the southwest. And we learned today that there's actually some terminology that talks about flares that seem to be going off at the same time in different parts of the geography of the sun. And it's called a sympathetic solar flare, which are pairs of flares that occur almost simultaneously in different active regions, not by chance, however, but because of some physical connection that from some they call it the magnetic attraction stuff on the sun.
Interesting. So I have to ask something about this down at the bottom. Is this like solar imagery iron 28?
Mm-hmm.
Yeah? Oh, okay.
So it's 94 angstroms, and this is a wavelength that's very sensitive to iron ionization, fluorescence,
All
or
right. Well,
luminescence.
cool.
And it's from
Awesome.
it's from the GOES X-ray satellite. It's designed to be a weather satellite, so it takes a lot of images in various spectrums, wavelengths.
Nice. I
Yeah,
knew it was because I look at this
its main
table.
its main job is to look at Earth with really beautiful high resolution imaging in normal light, and it's a weather satellite. But it happens to have a camera pointed at the sun, which does all this little stuff.
Cool. I love it. I love it. And I like how the previous slide gave us some context as to what was happening in these two areas. So that was pretty cool. Cool stuff. Good stuff. All right. And my chemistry teacher will be happy that I could remember that Fe was iron.
Yeah, you passed.
Oh,
I know, only periodically.
cute. All right, slide 3, we have a movie, which I know that you like these things, Gretchen, and so do a lot of the rest of us. This was from today, and you'll notice the same areas flaring, but we've seen the movie version of it. And the description that Mark put out there on it, well-known bunching within an hour of each other. You see the multiple events, and I just mentioned the sympathetic solar flare. We've seen that a lot more lately with in the solar cycle, probably because there's so many at once all on the surface of the sun that one's going to trigger another.
Right.
But I didn't know that they actually had all kinds of other terminology that described it.
That's interesting.
And I'm not convinced that there's a physical connection other than in time. But we'll see. We'll learn more about it.
Well, yeah, now that you've been opened up to that, you'll have more of an opportunity to keep an eye on it. Yeah, and I also really like when I can watch the clock down here to get some, again, context of what the time span we're looking at. So
Yeah,
that's
it's just a little over an hour, I think. Yeah.
cool.
Very quick.
All right. Ooh, so these are Canary 5. Let's check it out.
I think this is today's image. Yeah, these are today's images.
Yeah.
Also. I think I'm talking to these also. All right, you can see up again in the northeast. We've been losing filaments like crazy off the sun because of the flares are originating with the along the filament, and so these are some of the few that we've seen. Because we lost one yesterday, I didn't even notice it, but I had posted an image from one of the other observatories, and Hank pointed out to us in a message back that they actually had lifted off between the time we had our earlier in the day images in the southeast. The filament had lifted off with a solar flare. So here you see again AR 30, 35, 59 with several dots of bright flare plasma, and this cranked out so many solar flares today. There were M class and C class flares. There were actually 25 solar flares erupting in a 24-hour period, and there were 11 M class and 14 C class at last count before we started the session today. But you notice we have some really good images. They got a lot of detail in the surface of the sun. And then the next one is you got the southern part of the chromosphere, where you again see some filaments, and you have active region 3561. It looks like a couple flaring off to the left of it, some little smaller spots. And the other stuff in the corner is just the some of the overexposure of the setting on the telescope.
Well, that's great. And you can actually see some from it. Maybe over
Yeah,
here.
we do.
Little
Yeah.
tiny ones.
Here.
Yeah.
Oh, and here.
Mhm.
Cool. I love it.
We haven't seen as many prominences because those occur on the edge, but we're seeing an awful lot of things that if these flares were occurring on the rim, we'd be having some pretty good sized ones. We had a nice sized one earlier in the week and
So
last week.
this next slide, what is that, slide 6?
This one looks hot.
It's a still frame from a coronal mass ejection, which occurred just yesterday, and it's been labeled to show where it originated, the filament eruption that started it, and then it went on to pass the edge of the sun into the corona, and we can actually see the wavefront and a rather beautiful radiating CME, which is sometimes these in the movies you see they go so fast that they're just boom gone. And I thought it's really fun to see a still frame that's been processed to maximize the visibility of these things. So that's one that happened just yesterday. And the question arises, are these coronal mass ejections also coordinated in some way physically? So in the next 2 slides, you'll see some movies that maybe suggest this.
All right, let's do that. I think we have to stay.
Second movie of the doubleheader or triple header.
Oh yeah, for sure. And I think we have to stay. Maybe I can make it bigger. Oh, can you see that?
Bigger there, yeah.
Okay.
Okay, so here you are. So guess how many you'll have to hit
Replay.
reload or yeah, replay. Guess how many CMEs are happening in this short 7-second movie? There's 1, 2, 3. Did you catch them all? Don't blink. Try it again. 1, that's the big one. 2 on the limb.
All right, I'm
3,
starting
there's 1 in the
again. Ready?
northeast. Ready? Okay. 1,
I did, but the second one's quick.
2, and maybe 3. So they're also happening in rapid fire order. And this was yesterday. So in the next movie, slide 7 or 8, whatever it is.
Yep, slide 8, storms. Wait, come back right here. Okay.
Yeah. So in this movie, which occurred a day earlier, we have 1, 1, 2, 3. Another 3. If you don't blink and you're
Gosh, there's so
got
much like
good.
action. And you know, whenever I
This is the
see
last 3 days. Yeah. Yeah.
when I see these kinds of things, you're like, my mind like thinks that there's like some sort of a wound, right?
Yeah.
You know what I mean? And it's like, and how does it like
Well, it's an
balance back
emanation
out?
or eruption from the surface, but
Yeah.
it's not clear to me how they happen or why. But these filaments can be sitting there for a week or 2, and then they suddenly just totally go bonkers. They just erupt and
I mean, is it kind of like a volcano?
yeah, kind of or something. I'm not sure what. So this phenomenon of sympathetic flares also applies to sympathetic CMEs, which
Well, and
according
I got to
to
pause because I just looked over here. Holy cow. Look, do you see this?
what are we looking at here?
It's like,
Yeah,
promise. It's like, that's huge.
that is a huge one. It sort of rolled around, didn't it? And there's a CME that emanated just below it. That's number 3.
That's just incredible. You know, there's
So
so
I
much.
think we're scheduled that we could have an X-class flare this week from one of these areas, but we don't know yet.
And that'll knock out some ham radios or
Well, these filaments were supposed to cause some aurora and solar storming, but it hasn't got here yet. Or if it did, it was a sort of a dud.
Oh,
watch
yeah,
today.
I read about that there was projection that there was going
Yeah,
to be some pretty good auroras.
the news feed said it was the end of the world, but actually we haven't seen it.
Not
Hasn't
yet.
happened yet.
Not yet.
We're
We're all
having our
here.
meeting.
Hello. At least we think we are.
So a few days ago, there was another interesting phenomenon. This AR 3559 had just come around the limb on the left there, and there was this sort of nondescript filament uh, sitting up there in the northeast towards the pole, and suddenly it erupted. And this was not a very good seeing day, so the image is kind of fuzzy. But the next slide shows what happened next within an hour. The final slide, and that's a beautiful slide. So blow that up if you can. Anyway,
That is as
uh,
big.
okay. So 3559 is still there on the left near the edge, and this filament just went bonkers and threw a huge arch prominence, which targeted right at 3559. And it was on this side of the limb, so we could tell that it was from the filament, and further movies showed that it actually was anchored on one end in 3559 and the other end in the filament. So filament disappeared, erupted, 3559 got a charge out of it, and that wraps up our sunny report for the last 2 weeks. And we're really anxiously anticipating more solar pops and bangs in the
I
next few
love
days.
it. I love it. It was a great report. And yeah, the CME and the Aurora, I saw that being projected to happen. And then nothing, eh?
We're still waiting for the happening, yeah.
All right.
But it might anytime.
Right. All right. Well, thanks you guys. As always, very, very awesome. I know that there is a lot happening in our sky, including our friends, the Gemini twins. But I'm going to hand it over to Keith, and you can tell us like what's up.
Actually, there isn't a lot happening in the sky
Think
this
there
month.
is.
It's kind of quiet, but we get to look at some of the things that we've been looking at. There's some events. There's a very so I'm going to go into Solarium and look at two things that I think are of interest, maybe three. I definitely want to look at the Slooh telescopes. There's been a happening that was newly discovered. We get excited when things like this happen. I do have a potential wall of Hollow image at the end, actually a couple of them, since
Nice.
we haven't done that in a while. I don't know how I find those because I have officially stopped buying anything telescopic related. In fact, I am selling, but these did come my way, so I couldn't help but take a look.
Couldn't resist.
But before we do that, Gretchen, why don't you fill us in? I know that the main focus right now with Slooh after the new year is the eclipse. So fill us in on what's going on with this in coverage and where we are. I know we're still a few months out, but I know that we're going to have some live feeds and you're part of organizing this. So why don't you just give us what we have to look forward to? Because I know as we get closer and closer to the event, the crazier and crazier it's going to get, especially since we're every other week now. We don't have every week. We probably only have a month or two of biweekly shows to get us to.
Yeah. So right now we are looking at Nick will be providing a live feed,
Okay.
and that's kind of where we're at right now, and looking to, see what's happening potentially with like schools in the area, but that's kind of where that's sitting right now. But the other new news is that Russ will be repeating his professional developed webinars. And I just got the dates from him a few days ago. So I'll be scheduling that, but he'll be doing 4 of those and 2 different sets of 1 and 2 and 1 and 2. So you can see, talking about what eclipses are and how to best see them and all that kind of stuff. So those will be up on the schedule pretty soon. So yeah. Oh, but while I do have the floor, I want to and don't want to forget that if you go to Pix's chat in Discord, you'll find a thread that is specifically for the Orion Star Party that's coming up in February. And we have had a number of people already pick their objects. So if you would like to do a short 5-minute casual presentation on your favorite Orion object and what it means to you, please sign up and grab it before somebody else does. It's getting exciting. It's got a lot of different cool objects so far. So that's all I've got. Back to you, Keith.
Now, as a disclaimer, I like to call this the mostly Orion Star Party because
that's true. There's a couple.
There are a lot of objects that are kind of in the peripheral region that we would accept too, and I don't have a problem if two people want to gang up on the same object. I'm not going to present any objects. I may chime in. There's a couple things that I like to draw attention to in Orion, simply because they don't get the press I think that they deserve. I mean, Orion is kind of like a famous musician's catalog where everything is so well known about them that there isn't really anything left to discover. But that's not true. Orion is very, very interesting. In fact, why don't we go there? I've got that part of the sky pulled up. Not because of Orion, but we'll take a look at it anyway. What I want to look at here is a really great opportunity to see something that can be difficult to find. And we always talk about difficult to find objects are easier to find when we have a locator. And we've got a great locator here. It's getting dark later and later here, but it is dark now, although it's cloudy. We'll probably have rain again tonight. We have this. We have Jupiter. We have the Pleiades. I mean, you go outside, wherever you happen to be, and we look at the zenith in the southern sky. Taurus, Aldebaran, and Pleiades are almost as high as they're going to be. We did pass the midnight culmination for the Pleiades, which I think was back in November. Another missed opportunity. That's one of those quests that you have to get it that night. If you don't, you have to wait till the next year. I've not completed that one. And it's a shame because the midnight culmination, the highest point of the Pleiades, really happens for like a month. Okay. I mean, it's a variance of like half a degree over a week. So it's not really that big of a deal. But anyway, we can't do that quest. But what I wanted to look at was this midpoint between the Pleiades and Jupiter, almost halfway between the two. We have an opportunity to hunt down the planet Uranus. So this is one of those objects, if you have not seen it live, this is a good chance to go out and find it simply because of where it is. It's not near a great locator, but it is in this midway point between the Pleiades and Jupiter. You have to make that leap of faith and just kind of hunt and peck around. And if you have a pair of binoculars, you should be able to see it. How can you tell it's Uranus and not a background star? Well, Uranus will take on the look of an airy disk, and that's typical of all the planets, whereas a star usually is a pinpoint of light. The last time I saw Uranus was during one of the lunar eclipses that we had, where Uranus was very close to the moon. It was gorgeous. It was right by it. You have the full moon eclipsed with a total lunar eclipse. Uranus was right there. And later, in another part of the world, a couple hours later that night in Asia, we had an occultation of Uranus. It was an exciting event. Anyway, it is a chance to go out and look for this. 5.71 magnitude. Uranus is on sort of that cusp of what is visible and what is not visible with the naked eye. If you live in any place that has any type of street light or town somewhat close by, you need binoculars, but you don't need a telescope. You can't go out and find this. And especially the wider field of view will give you more of a chance, a fighting chance to find Uranus between Jupiter and the Pleiades. So that's thing one that I want to look at. Thing two, of course, is Orion. This is the Orion Star Party. Lots of good things to look at. Some of these Orion objects are objects, again, that we are not going to see without the aid of long exposure. So I didn't see the list, the complete list, but I do know one object was chosen, which is definitely not something you're going to see. You're not even going to see it really on Slooh. You need to have some processing skills to be able to tease it out. But there's a lot of good things here. Again, if you are not a stargazer and aren't really familiar with how to find your way around the night sky, this is the time to learn how to do it. The three belt stars take you up to Aldebaran and the Pleiades and Taurus. We make that loop, the winter hexagon, up to Capella, the bright star in Auriga. Menkainen is the other one. The moon happens to be in Gemini right now, but it'll move. Castor and Pollux in Gemini. We loop around to Procyon in Canis Minor, and then Sirius in Canis Major, and then back to Rigel in Orion. If you don't mind staying up in the middle of winter, a little bit later, maybe around midnight, and look between this area of Castor and Pollux in Gemini and Regulus in Leo, you will see the beautiful Crab Nebula, I'm sorry, the Beehive. I love the Beehive in springtime because it's in the western sky and I don't have to look up very high to see it. So that's object 3 or 2. Object 3, where do I want to go next? I want to get up my clock. And we're going to look in the eastern sky. And let's make it about, so you can see, Regulus will make its way through the sky. So if, let's see, 3 o'clock. Yeah, you're like 3 in the morning if you want to see the crowd. I'm sorry, the Beehive, more or less overhead. But I want to go to dawn. Let's take it about 5:30. And I think I have to be right around 6. I do. Sorry. You're going to see this starting to happen. What's going on here? Something's wrong with my times. But in the pre-dawn sky, you are going to see a very close call between Mercury and Mars. And this will become almost at 7 o'clock. So we're really pushing the limits here. I was looking at some other projections and they were saying what's visible. Ugh, this is really close. Venus you can still see in the early morning sky. Mercury, Mars. Mars has returned, but I'm looking at this stellar here, 7 o'clock. That's like way too late to see something that faint. I don't know. Now
Yeah, that's dawn.
I was looking at one of my
Full on dawn.
sites, and they were saying to look for this. I didn't run the projection here. I don't know. Let's advance the day, maybe. So we're going to lose Mercury as Mercury loops around. And of course, Mars will rise higher and higher. Mars has returned to the morning sky either way because we have past solar conjunction, which is where Mars is on the other side of the sun. The Earth is looping around Mars, and we are approaching opposition with Mars. But that won't be till January of 2025. Remember, Mars moves half as fast as the Earth does. It's not that far away from us. So it isn't as slow in its course around the sun as is Saturn or Jupiter. So we will not come in opposition with Mars until next year, but we are approaching it, just a matter of catching up to it. So let's take a break. It's bottom of the hour. I'm a little disappointed with this. I was told that, yeah, we're going to see this great Mercury-Mars conjunction. I don't see where that's happening, but I don't know. You can go out and take a look for it anyway. It's worth a shot. Thoughts on this, on what we're looking at in the night sky before we go over and take a look at the Slooh telescopes? I may, you know what? Let's do this. Okay, let me get out of this for the minute. Thoughts on the night sky? What are you guys looking at, if anything? We've had clouds here, wintertime, so it's a little tough.
Miss Gretchen, could you repost the Orion Star Party information and pictures so
Yeah, well, it's actually
or I can go hunt?
it's in a thread. So let me look to see. Is it gone? Did it go away? Yeah, I will go ahead
No,
and see what the heck happened there. Oh
well, I
shoot.
haven't searched for it yet, but I need to get a mission in or two if I possibly
Well, we
can.
will go ahead
My
and schedule the
my
missions.
favorite object.
Yeah, let me see here. Here
Oh,
it is.
okay.
Right
So I
there.
have to.
I am
Okay.
going to just go ahead and tag you, and it should show up again if you take a peek. Okay, so yeah,
In
so
pixels.
there's supposed to be the planets in alignment coming up, and but we've had rain and clouds and nothing. There's nothing to see here, although it's supposed to clear up and we'll have some sun.
Okay. Thank you very much. I'll read
Well,
it and do something about it tomorrow morning.
this is where we have a chance to really take advantage of Slooh telescopes. When we can't go outside, there's something to look at. We don't have that benefit of seeing something and saying, hey, let me go out and see if I can find it on Slooh. So we work in reverse, and this caught my eye. There's a couple observations caught my eye, but this one in particular, the NGC 4216 with the supernova. If you're not familiar with this sort of edge-on galaxy, we have it where we're not seeing the flat plane like we see. Well, Andromeda is kind of an edge-on too. Think of like the pinwheel, the whirlpool, where we see it face on. This is edge-on. If you don't know where the supernova is, I realize that this is in the object guide, and we can go to it, the Discus galaxy. There's lots of observations of this. So the way that we determine whether or not we have a supernova is to look at the before and compare it to the after. There's one here that I liked. It was really good before. I think it was this one, Cameron's image. So we get a pretty good idea. It's not great resolution here. It's a little fuzzy, grainy, noisy, but we get that image there. And I can go back to my image of the supernova image, and we have no problem in figuring out where it is. It's obviously easier if you do this side by side. This is it here.
Oh, wow. Okay.
So we have another supernova event here on Slooh. I don't think I've ever seen a supernova before I started using Slooh. So again, this is one of the great things that we get to see with the Slooh telescopes. In a normal astronomical community, your local astronomy club, they're not seeing this kind of stuff. Because first of all, galaxies are so far away, you need a certain aperture, you need to have a certain amount of power, right, to be able to see a galaxy at all. Galaxies are so far away. When we look at these background stars, anytime you see a star and it's not a fuzz, okay, when it's a star, an actual star, just a star by itself, uh, that's an object in our own galaxy. That's in the Milky Way galaxy. The closest star is the Proxima Centauri B system, which I think is, what, 4 light years away. After stars, we have star clusters. The Beehive and the Pleiades are the two closest open star clusters to us. I don't know, I think about 400 light years away. After that, we have globular star clusters. They're 40 to 60,000 light years. What? How do you go from an open cluster to a globular cluster? Well, globular clusters are in the spiral arms of the galaxy, actually closest to us, because we simply can't see through the core of the galaxy into the other side of the galaxy. We're only seeing what's in our neighborhood. Globular clusters we can see because they're in the halo of the galaxy. They're out here. So we look at this galaxy, your let's say that's where the Earth is, where the supernova is. Open clusters are around that area. globular clusters are out in the halo, 40 to 60 to 80,000 light years away. Galaxies, Andromeda Galaxy, our local group, Andromeda, Triangulum a little bit further, a couple of the other smaller things like the Magellanic Clouds, 4.5 million light years from us. So the idea of these island galaxies, objects not in our own galaxy, it's sort of like you're North America and you got to travel across the ocean until you reach land again. And that's kind of what you have with galaxies. Galaxies anywhere from where we're at, like I said, 4 million to 4 or 5 or 600 million, half a billion light years, to quasars 10 billion light years away. So as we backtrack to this galaxy, I think this is, I forget, it does say in the guide. I closed up the guide. I don't remember. You can look it up. The fact is, in this image, we are not resolving individual stars in the galaxy. So the question becomes, is the supernova happening? Is it a star, a foreground star, or a background star? Or is it something in the galaxy? We really don't know. There's no way to know that. But what we do know is that we can see this bright dot of light. This is a good one. It's nice and bright. Sometimes you see these nova events and they're very dim. This one was discovered just in the beginning of January. And it is getting brighter. It will get brighter for probably a couple months and then will dim over a couple of months. When I was looking at this, I scheduled a few missions which are running later tonight. It also caused me to remember the Whirlpool Galaxy Nova event, which I think we all kind of just forgot about. So I scheduled a mission or two there too, just to see if there's still anything going on with that. Did anybody catch a look at this before we look at some of our supernova types? I was kind of excited to see this. I wasn't expecting this, although it's kind of all over Slooh right now. News to me. I haven't really been following very much, but I thought this was a good one.
I did. I scheduled a few missions, but that all the scopes were clouded out that time. So I had to schedule some after these observations were posted.
Yeah, so you should have a couple months. Like I said, this was, I think, a January 4th discovery by that gentleman who I think is in Hawaii. I forget his name. He's Japanese. This is his thing. He discovers supernovas. It's just what he does. He's very good at it. Seems every time that one is not discovered by a sky survey, which are just these computers that complete the sky, they're discovered by him. And this is another one of his. So I thought that was
cool. Why do you think that is? Is it something that he particularly looks for?
I would say that I didn't look at the time that this was discovered or what part of the sky it was discovered in. Actually, I have it in Stellarium. Why don't we go in Stellarium and see where this thing is?
He must be like,
so
in certain areas, why it's him all the time.
This guy has a go-to telescope that he takes pictures every night. He can see, and he may survey hundreds of galaxies a night, and maybe several hundred a week.
Wow.
To do as well as he does. Yeah.
I always wonder, like, what do these people do? Are they retired, or you know what I mean? Because it's like how do they find the time to do some of these things,
Well, I think there's one person that I read about who liked astronomy. I think he had a company. Maybe it's the same Japanese person, but he built his own little observatory and his telescope. And
I
mean, this is not just a hobby. This is
what he does, his life. Okay, I gotcha.
He's a supernova blogger or something in Japan.
Cool. He's a supernova influencer.
An influencer, yes.
Yeah, well, it's not so much how my question with this is why. I mean, okay. I mean, I could see after your first or second one that could be exciting, and you get your name on the board, and big deal. But I mean, to just dedicate all of your time to it's, I don't know.
Well, everyone has different obsessions, but this is a telescope object, correct? I mean, like a backyard telescope.
No, I'm sure he's got more than a backyard. I was
Okay.
thinking, why does he discover these things? I
Yeah.
was thinking of the example of our late friend Dale Machholz, who was a comet hunter, but he was looking for comets that were closer to the horizon, looking for things that were beneath the sun horizon of that 30 degrees. So because he had that, he was able to see that part of the sky that a lot of the larger observatories weren't able to look at because of the facility, basically because of the wall. If you've got a wall, telescope can only go this low. Well, you've got 10 or 15 degrees of horizon that they can't use, right? Because they got a wall. He could point his equipment lower. And because of that, he discovered dozens of comets. So one of my instincts wants to say that maybe this person is catching galaxies that are in that lower part of the sky. And when we look at this one, this is where I went into my stellarium. Now, this object actually for me isn't even visible yet. So you have to go to 1, 2. Let's see how high this gets. Okay, it's going to make its way because it is in Virgo. So it is a zodiacal constellation, which means it's going to follow the path of the ecliptic. If it were lower down here, like objects, let's say, for sake of argument, in Scorpio, in Scorpius, uh, the further north you are, the less of Scorpius you see. So I could see how that would be, kind of come into play, or anything south of Orion, if that makes sense. This isn't, I mean, this is right on the path of the ecliptic. This is zodiacal. I wanted to look at this too. When you go in here, an interesting thing is, why is this a good place to look? I have to turn on my deep sky objects. Remember, this is in that Virgo cluster region where we have all these galaxies. Everywhere that you see a red dot, that may appear as a smudge in your telescope or a dot. You may even think it's a star. They aren't. They're galaxies. This is that extremely rich galaxy region in Virgo. It's not just Virgo. You also have it here in Leo. Let me get over here. We're in Denebula, which is the tail. Remember, Deneb is an Arabic word meaning tail. So that's why Deneb we have in Cygnus the Swan. We have it here at the end of Leo. We have all of our galaxies here too. You have the Leo triplet group over here, and you've got the Leo galaxies.
Yeah.
You've got all the Virgo galaxies. You've got the Coma Berenices galaxies. They're just galaxies all over the place here.
So let's think about this a little bit.
Sure.
If he's got an observatory on a hill, he's going to be surveying the western sky as it goes down, so he sees it as soon after sunset as possible. And he can go through 100. If he has a go-to telescope and a little bit of a computerized program, he can image 100 galaxies a night, maybe more, maybe several hundred. And people spend hours and hours getting an image of, say, the Orion Nebula or the Trifid Nebula, and this guy spends hours and hours getting hundreds of galaxies on his electronic imaging system. And then he can, the next morning, he can still sleep as long as it's working. And the next morning, he can scan through these things with some sort of comparator program, blinking.
I mean,
So
you'd have to have
dozens
some
of
sort of
galaxies.
comparative program. That's what I was thinking too, Mark.
Yeah. So he probably has that automated as well. That's pretty easy for a computer savvy guy. And then picking the galaxies you want to use. There's lots of galaxies that are not good candidates for supernovas, but there are like those big old ellipticals that you're looking at now. But the more star intensive disrupted galaxies, especially, will have more supernovas.
Yeah, active galaxies, that
Yeah,
kind of thing. I'm here because where we're
interacting
at,
galaxies. Yeah, yeah,
yeah, we're in this area of Markarian's chain and the eyes, and these are popular targets
right.
on Slooh. So we're not very far. We're up here. Let's get out of this. That's where it is. The question becomes, why do we have all of these galaxies in that region? And it's about something that we talked about a while ago. Let me, where did I put this? Here we are. And it has to do with what I kind of talked about at the beginning of our little talk here when we look at the night sky. When we look upwards, whether we're using a telescope, a pair of binoculars, Slooh telescopes, or whatever, we see everything thrown together in a lump. We look up, we see the moon, we see planets in the solar system, we see things outside the solar system, we see stars. These are all objects in our galaxy, but we also see things outside of our galaxy, right? We can see other galaxies. We can see objects in our local group, or we can see what we saw in Virgo. And the reason we see that dense concentration of galaxies is because we're looking at a patch of clear sky that's allowing us to see out into this Virgo supercluster that we're a part of. It's part of this Laniakea. We are here. This is our local group. And we're actually part of this larger Virgo supercluster of galaxies. So when we look in that region of Leo's tail and Coma Berenices and that area of Virgo, we're looking into this curtain that has been pulled aside, and we get to see all of these galaxies that are part of this supercluster. We're not looking at the local group anymore. We're actually looking out very, very far away, out into this larger region of space. It's kind of exciting. And like I said, galaxies are difficult to resolve into anything. But when you are in that region, even with binoculars, you know that you're in a galaxy-rich region. You know that what you're looking at may not be stars. They're probably galaxies that are just so far away, and you don't have the resolving power. They may just appear to you as points of light. So
That's a beautiful image, by the way. Beautiful illustration.
yeah, you can look for this. It gets bigger.
Oh
We go
wow!
from
Yeah.
we go from this image, our local group, the Virgo supercluster, to the local superclusters, which the Virgo supercluster, which is this whole region, is actually just a dot in this much.
Just remember, every dot on that picture is a galaxy. Wow.
Yeah.
Or a group of galaxies.
And of course, that's just a simulation, right? So
that's gorgeous.
I think that's okay. I'm sorry, observable universe. So the local, that previous slide is a dot in this one. So when we look through, and that's I think the cool thing. We go outside. I think most people here have a dozen images at least of the Andromeda Galaxy. It's close. We see it. It's still very, very far away. Okay. It's millions of light years away from us. It's not like it's close, but it's relatively close when you look at something like this, and that to me is just so interesting. When we look at the Hubble Deep Space image, you take a size of the postage stamp, hold it up to the sky, there's nothing there, and they leave the exposure, the shutter open for a couple months, and we have, I think, 40,000 galaxies. When you take a pair of binoculars and look up into that no man's land between the tail of Leo, the nebula, and over in Coma Berenices and the region of Virgo, you know that you're looking into this region. It's like a curtain that's been pulled away, and you get to look out into deep, deep space. And of course, with the Slooh telescopes, we are able to resolve those individual galaxies, like we have with the Discus galaxy that I had up earlier, and to see this supernova event. This is not something you can do at home most of the time. Sometimes you can, but that's what Slooh is great for. That's what Slooh does best. I always say that with the Slooh telescopes, what Slooh does best is, for the most part, what we happen to be looking at that particular moment. So let's get him back up. Yep.
I think the
Supernova.
most distant galaxies on Slooh is something like 240 million light years away that you can see on Slooh objects.
We've had 500 million. There's 500 million or more. It shows up as, I forget, we did it in astronomy camp. There's a popular Slooh object that has a galaxy in the background, kind of like one of these. And the galaxy that is the featured galaxy is, I don't know, relatively close, 50 million light years, whatever. But the one behind it is 500 million. That's crazy. And then we get into, looking at quasar.
That's amazing. Yeah.
For 10 billion. It's just a speck.
Yeah.
But it's 10 billion light years away. That's crazy. 14, I think, is the record. I think it's the smallest star that we have seen on Slooh. We have a little time left. Thoughts on this before I think we have time. We'll take a look at some of these supernova types. Maybe get an idea of what exactly is happening with this.
Did you see Sedona had a question asking if you could post a link to where you got those images?
Yeah, I don't remember.
The galaxy images.
That's one of the things I don't like about Discord.
The,
if it were me,
the illustration.
I would post the file. I would just post the file, and you could have access to all the images. We don't have file sharing on Discord, and that is a shame, because there's so much stuff that I have. I would just put the whole file in. I would do that for when we were doing a weekly show. I'd have 30 slides in some cases. We might get to 10. I would just post the whole file. Andrew Z. Colvin, I think, is the guy's name. If you look him up, he did a complete slideshow of the whole thing. Andrew, I'm sorry for watching this. I'm sure you're not, but if you are, I'm giving you proper credit for this. I don't know what the terms are. I don't even remember where I found the stuff. If you look for images like on Wikipedia, if you click on the image, it will tell you what the use is of the image. If you can use it free and clear, if you have to make attribution, whatever. I don't remember where I got his images, but I will certainly try and figure out a way to make some of those available.
Perfect. Awesome.
All right. Before we have some fun and look at our poster child for the week,
I'm excited. You're like kind of built this up a little bit. So
these are good, believe me. All right. So we look at the type 1A, which is one type of supernova. We'll look at him too, but let's look at type 2. We don't talk about type 2 very much. I just have a feeling that's what this is. Don't ask me why. We know that stars, in the stars that we see in the sky are either single stars like our sun, or they're multi-star systems. 2 or more stars are actually the norm. Greater than 60%, the current belief is, yeah, those stars are binary or tertiary, or have more stars than just one. Let's look at type 1. First of all, the size of the star is going to determine how it ends its life. So, stars the size of our sun, or smaller, or even slightly larger, will reach a point where they are no longer main sequence stars, meaning they can no longer turn hydrogen into helium at their core. Nuclear fusion is stopped. They start running out of fuel. They start consuming other things. The core suffers collapse, and the outer shell will expand and just kind of go poof, and will turn into a planetary nebula. We see these on, planetary nebula are not very long-lived relatively. That's why we don't see a whole lot of them. They're very far away for the most part. They're small because there's a white dwarf at the center, and the cloud of gas is usually not very big. It's not like the cloud of gas like the Orion Nebula, which is enormous. These are relatively concentrated. They're small. They're not very big. And that's how our sun will end its life. And planetary nebula, I don't know, think of Ring Nebula, Helix Nebula, Cat's Eye Nebula, Ghost of Jupiter Nebula. Those are your planetary nebula. Stars that are much, much larger, these so-called blue-white supergiant stars, will end their life in some form of supernova, where, again, they run out of fuel. They start burning up some of the other stuff, the junk, the heavier elements. The core will begin to collapse, which causes, again, action in one direction will cause an opposite reaction in the other direction. And because of the force, it will cause the outer shell to simply explode. The star will just basically blow up. Stars that are healthy are in a type of equilibrium. There's a lot of pressure at the core, but because of the mass and all of the pressure exerting down in it, you have this force going out like this, and then you have this pressure going in the other way. And the star is in this state of equilibrium while it is a nuclear furnace. At some point, when that starts to break down, it becomes more and more unstable. And that's when you have these nova type events where you have some form of explosion. I wanted to look at this. Then we have the type 1A supernova where you have a binary system. And, one star will go into a type of planetary nebula thing, an event. You still have the companion star. They start to share mass. The white dwarf reactivates at its core, and then you have some type of explosion and the other star gets cast off. We've talked about this before. I don't want to spend a lot of time on this today because I don't know what type of supernova it is. What I know is that we're able to see it, and that to me is the exciting part. Okay. So it's almost top of the hour. I haven't done a lot of research on this. I just kind of found out about it the other day. Like I said, I wasn't really thinking a whole lot about it, but we talk about these events all the time because we have more nova events than we do, I think, any other great type of event on Slooh. We haven't had a good comment in a while. I can't think of the last one that we did have. When we have a good one, they're great. Nova events are very exciting, but for what they are, but they're not spectacular in terms of what they look like. We just see that dot getting bigger and bigger, and then we see it getting smaller and smaller as the star explodes and then gets smaller in the.
Well, Sonali has posted
All right, let's take a look.
a couple of nice images, infographics in Discord on supernovas. So just FYI, if you want to check those out. Sonali, if you wanted to say anything more about those.
They're just quick summaries of what Keith was explaining, the classification and how type 1 and type 2 supernovas are differentiated.
Awesome. Awesome. Thank you. I like that. I'm looking at it and it's nice. It's just packed into a nice little easy to understand summary.
Yeah,
Thanks, Sonali. That's
whenever
great.
whenever we talk about any of this stuff, you can go into some of these articles and just, open them up, read 2 sentences, close them up and say, I'm done. I think it's more important to see things like Sonali slides or to look at those pictographs and just kind of have a random open understanding, general understanding what's happening, because it's very easy to get carried away with a lot of formulas and science and chemistry and that kind of stuff, when it can be understood in a different way, just at least in theory. And so much of space is like that. I don't want to say it upsets me, but it does kind of bother me when you see a lot of observations on Slooh, and they've obviously copied and pasted a Wikipedia article from something, and it's just not a good observation. There doesn't tell you anything that you couldn't have looked up on your own. I think it's much.
There's not that personal sort of aspect as well, which again, for the Orion Community Star Party, that's sort of the point, is we're getting people's also, what's your perspective? Why do you like this object?
We don't want to hear how far away you can add that in, but or what we want to hear, why did you choose this object? What is the big deal? Hank's presentation of Hatisa, people still talk about that. People still remember that object just because people don't talk about that object very often in Orion. So that was kind of exciting.
I know it's now the subject of cocktail parties all across the world.
It's all over the internet.
You remember that time Hank was talking at that Orion?
But we know that we're going to see the Horsehead Nebula, and I have mixed feelings on the Horsehead
Well,
because
you just hold those.
yeah, I know. Well, it's been 2 years, but if you have a good memory, as I said, I'll leave it at this. This is my not spoiler alert, but some of these objects in Orion, the Horsehead is one,
Mhm.
really need the help of of camera work. You need to
Oh,
be
yeah, for sure.
exposure
For
and that kind
sure.
of stuff. It's not like
Absolutely.
you're just going to go out and see some of the things that are going to be talked about. I am going to pull out some of my special slides of when these objects were first discovered, and I'll tell you what, they look a lot different than what we see on Slooh. All right, I think that's enough of that for today.
Okay, so let's go. We've been teasing us all night with this fantastic Hall of
Yeah,
Wallov.
so let's go here first. We have some new images. So if you remember, I am still, I'm not sure why, but I am still a member of the Antique Telescope Society. And I talked about this before. The topic of distinction, these 17th century singlet refractors, telescope 101 in 15 seconds. Doublet has two lenses, the singlet is one, triplet is three. It's meant to correct certain things. In the 17th century, they didn't know that. They only had one teeny tiny piece of glass, a lens. These star tests down below are extremely good. Okay, these are very good. You can see the size of this, all right? It's like the size of maybe a $50, maybe a quarter. I think I think these are 40 millimeter telescopes. Does it tell us here 27? Oh my gosh, 27 millimeters. All right, that's tiny. All right.
1 inch. Yeah.
This is the telescope that he made according to ancient plans. If it looks like a copper piece of tubing, that is what it is. The very, very long focal length is meant to correct for spherical and chromatic aberration. That's the objects out of whack and false color. What else? What was I going to say about this? That also means the part of the sky that you're going to see is very, very small. Okay. Again, think about looking down a soda straw versus looking through something like a chip can. You're seeing a very, very small part of the sky. But for the kind of work that these were used for, like double stars, you don't need a large part of the sky. It'd be very difficult to find because you've got to, imagine looking the night sky through a star. Anyway, I just love
Yeah, I
this
was
build.
gonna ask you like why somebody would make such the long and skinny when you could make it shorter and wider. But that makes sense if you're like trying to get rid of all the extraneous sky and really focus in on
Well,
the double star.
there were practical reasons. First of all, you're at the beginning of optics. I mean, we didn't have telescopes until right around the 1580s, 1600, 1640, I think is Galileo. You're very early on. Glass was expensive, so you just didn't have the technology. And they did understand, of course, that you had this false color and you had things out of whack, what we would call spherical aberration. So it was discovered that if you lengthened the length of the tube, you would be able to factor a lot of that out. And that's why you had that. The idea that this whole thing of large aperture, short tube thing, that's a modern thing. Okay, that was only really that thing since like the 50s.
Well, you made a really important point there, Keith, in that for the layperson, the backyard astronomer trying to get the cost of materials, at that time was prohibitive for many, correct?
Oh, sure. Still is.
Yeah. So I don't think it's something that we really take into consideration.
Yeah. To give an idea, a 4-inch copper tube this length, this is not a 4-inch, but I mean a 4-inch diameter would probably run $1,000. And a 4-inch lens, objective lens, is $1,000. I mean, you can buy a 4-inch telescope for 150 bucks. That's a short tube.
Yeah.
But to get something in this length, I know because I have one. I bought it from a guy who built it. The tube weighs a ton. I don't know why he chose copper when he could have used PVC, but he did. The scrap value of the tube is worth more than I paid for it.
Wow.
Anyway, this is what these telescopes can do. So we think, the 17th century telescope, we looked at this before, something in the 1600s. This is a moon image. I don't know, you tell me. Not too bad. Now here we do have some false color. But I'm going to cut him some slack on this. I think that's pretty good.
I think that's pretty darn good. What was the year of the telescope?
Well, this was built according to older plans, but we're talking, 17th century, let's say 1650. We'll just split the difference. So this is the type of images that they would have seen. We think that, that's kind of the whole thing, this idea of multi-generational superiority, that each generation is somehow better than what came before it. I don't know. With one small little lens that's an inch in diameter, producing moon images like this isn't too bad. I don't know. We looked at some of these before, but this guy has posted more moon images. That's why I wanted to share them. So that was fun little thing number one. Fun little thing number two, talking about historic instruments. Let's look at this that came up for sale. I always do these. I know this has nothing to do with Slooh, but hey, it's the history of astronomy. This nice little telescope, I think, is an 80 millimeter French refractor, almost 200 years old. You can buy this for $1,000. Two eyepieces, really nice. I want to go back. There's another one that he has for sale. That again is a.
Don't you want to just like clean that lens a little bit?
He doesn't charge extra for the depth. I wanted to mention that, but I wanted to look at this one. This was the Gilbert 4-inch. The reason this is important because he did enclose images of what this thing can do, which usually they don't. Usually they just show the telescope, but they don't show us what it can do. So this is a 4-inch f/15. I think he wants $3,000 for this. So if you've ever wondered, we're going to see what telescopes like this can do. And usually, I love showing this when we look at these antique instruments. How good were their optics? All right. This lens is not as bad. Nice and clean.
It's a little cleaner.
Look at this. I love this. So he's got 4 tube rings. He's got it stabilized to a piece of wood. So he just bolted the tube ring to this little piece of wood. And obviously has like a dovetail attached to the piece of wood here, and it's bolted on again. I love this. Great, look at this. No diagonal in those days. You've got to get down on the ground and look through this. So that's not a joke.
You're gonna have to limbo to look at that.
They weren't using tripods, that's for sure. They were using tall columns.
So here we go.
Okay.
Or leaning it out a window.
$300. This is the setup. You're looking at it. You're looking through it from the ground. Proof in the pudding. This is a daytime image. Let's see if it's worth it. Okay. So this is what he's looking at. He's looking at this little chimney down here. And this is what we've got. Thoughts?
Well, it's not really that far away.
Hard to know what it is, yeah.
Well, the thing is, we see these things, if you ever see these beautiful looking telescopes, this is the type of image, and this is consistent with what I have seen from telescopes of this grade. I don't know. Good, not good, worth it, not worth it?
No, that's not that far away. I mean, if you wanted to use it to look at, deep sky objects, you're gonna see. Come on, that's not that far.
Really hard to know. He needs to have a deep sky object image.
Exactly.
Like the moon.
Maybe he's afraid to show you that.
Mm-hmm.
Yeah.
Well, here's the other thing too, is
Yeah,
like how much light does it grab? You know what I'm saying? I mean, this is
4
during the
inches.
day.
4 inches, yeah.
It's a 4-inch
F15,
diameter.
yeah.
Now here's some things that I picked up on immediately that he's not advertising.
Mm-hmm.
First of all, he doesn't tell us if he inverted the image or not.
Oh, interesting. Yeah.
Astronomical refractors will produce an image that is a mirror image. It's inverted. It's back. It's back and forth. So I don't know if that's the case here,
I'm
or if
like,
it's upside down, because
that
that's
object
how
is
you
not
tell.
very far away.
That's how you can tell if it's an astronomical telescope or a terrestrial telescope.
Mm.
Like a harbor telescope, you would be out, on the bay and you're looking for ships coming in. I don't even know if this is made to look at the stars. Sounds crazy, but just because you see what we call a telescope doesn't mean that was its intended use to look at the stars. So you're right, we don't know.
Good point.
But either way, looking at it, I would say it's a wall hanger. It's nice to look at. I've seen enough of these images. No way would I spend $3,000 for something that produces this.
No, unless you just like the look or you've got
Not
like
when you can go to
Yeah.
Astromart on sale. They have the big 5-inch triplet on sale for, oh gosh, some insane price, like $1,400 around Christmas time. Half the
Wow.
price of what this cost for images that are as good as you can get anywhere. All right. So we're just about done. We have the 4 minutes left, and this is the time where you as a panel get to decide whether we have a Hall of Fame or a Wall of Shame image.
All right.
And this is this. I know what it is in my heart, but I'm going to allow each of you to decide what you think.
We all get a vote.
I
Okay.
want to see where you would put it. So
All
here we
right.
go. This beauty came up for sale. The person actually wanted money for this.
Ouch.
Okay. He had a price on this. Was not willing to ship it. If he was willing to ship it, I definitely would have bought this. Even though I'm not buying telescopes. So we have obviously some wear and tear to it in the dew shield here. Interesting solution here. He used like bungee cords to anchor on the dovetail.
Hmm.
There is, I don't know what this is, like a nail or a screw.
Looks
He
like a nail.
understood.
Yeah.
He understood that because these are going to interfere, he had to make the dovetail long enough so that it would fit into the mount and not interfere with these bungee cord things that he has on. I don't know. He could have also used zip ties or like those hose clamps, but he didn't. It gets better. We have
I hope
this.
so.
So we have the focuser. There, if you notice, there is
Did he like take a cap off? Was there like a cap on that or something?
Yeah, this is an old draw. This is a draw tube. So telescopes for the longest time there were 2-speed focusers. You wouldn't think they are, but they were. You would have the draw tube, that would be your rough focus, and then dial, the knob, was your fine focus. Your rough focus was achieved by moving the tube in and out. And that's all this has. It doesn't have a knob anywhere, so it only has a draw tube, which, as you can see, is held together with a mixture of masking tape and I'm not sure, I guess electrician's tape.
It
He
looks
does
like,
have
yeah,
diagonal.
electrical tape and
I give him
very-
credit. He's got a diagonal, which it looks like he took a piece of plastic and cut it and probably put a mirror on it
looks like foam board or something.
and screwed in
Yeah.
PVC thing.
yeah, and he's got to probably tap the hole in for this screw to keep the eyepiece
Right? Cap screw.
flowing out.
Okay.
Unless that is the eyepiece. I don't know. That's our telescope for today. It could have been yours if you lived in the area for $40. Like I said, he was
Oh,
charging
40.
$40
he was
bucks?
asking
Did
money
did he
for
give
this.
us any pictures? Any like what you get out of it?
Well,
No.
I'm
based
sure he
upon
didn't.
judging by what you see from here, do you really need them?
Yeah,
Doesn't
I
this
think
kind
that
of doesn't this say it all?
Well, Hank is asking no mount. Did this not come with a mount? You have to have your own mount?
Hey, he's giving you the dovetail. I showed
Well,
you
you
what
know, I
three
don't know. I
grand
mean,
does. I showed you what 200-year-old $3,000 gives you. Look at this. What do you think this gives you?
well, you already said
this
that if
this
he
guy
shipped
this
it,
guy may have
you would
made
have
this when he
bought it.
was 12 years old. So he thinks of it as
He
something
said that if he
sentimental.
would have shipped it, he would have bought it.
This was listed as a starter telescope, and you're right. He did. This
Yeah.
is an ATM, amateur telescope maker. Yes, he did make this. When I don't know. Oh, he did use Hank. He did use a hose clamp. We couldn't see it in the other views, so yep, he's got that in there too. But he also has the bunch. I guess he
He has
wanted.
two different kinds of
He
bungees.
does. He wants to make sure it doesn't move around. Okay, he
Two
didn't use.
different kinds.
Okay. All right. Well, that
Hank wants to know, is there any glass? Do we know?
I'm assuming it has an objective lens. Yeah, we don't see it, but I would assume it does. So that's our
Maybe it was his
hot tip
first
for today.
refractor.
Do we have to take
That's
a
kind
vote?
of
I
interesting.
know where I put it. Hall of Fame, Wall of Shame. I don't know. I don't even think that would even make it on a wall. Uh, maybe a special room for objects of this quality of this.
Well, I'm gonna just chime in here in that, ingenuity. Okay, I'm giving him votes for that because I like anything where people like
Yeah, I would
hack
too.
together stuff from like common household goods. I'd like to see like what it sees, but the fact that he's like piecing this together and making a telescope, I'm going to give a vote. I give my vote for Wall of Fame. I'm doing it.
Well,
Because
I told you
he's charging like $40. Okay. If he was
I told
selling
you my
this for
thoughts
like
on it.
$500, I'd be
I
like,
would have
huh,
bought it.
wah, wah.
If this were local, I would have bought it. I wouldn't have paid
See,
40.
there you go.
8-inch one.
There you go.
Well, just to have it. I mean, we've had a lot of these things come through here over the years, and none of us own any of them. We've got to have at least one
Yeah.
somewhere.
I'm like I said, I'm giving him a vote and a high five for points for ingenuity. That's where I'm coming from.
I would take this up to one of those fancy clubs where they
He
can't
had to show up.
find a star to save their life, and they've got to sit there for half an hour and a line, and you take this thing out, just start cruising in the night sky on a.
Okay, so hey, here's Hank's great comment. If he was challenged to make a telescope out of spare parts in his basement in 12 hours, I'm going to add in a hoodie. This is extremely well done.
Okay.
All
Yeah,
right.
if he was 12 years old and did this, she'd never sell it.
Well, I just still think, it's like he uses that little PVC part. I mean, it's like he's scraping through a box. Like, how could I put these pieces together and make a telescope? Or was he like, I want to make a telescope. What spare parts do I have? Which came first, the chicken or the egg? I'd love to know his
That's definitely
process.
a plumbing fixture there. That's very
This would
nice.
be perfect on a
40.
homemade pipe mount.
Yeah.
This is
Yeah.
my question here. This to me is a design flaw. I would have just run this straight through. You put the eyepiece right on the thing, the draw tube. That's this diagonal. I don't see
Yeah,
this
I'm
work.
not quite sure what that's for.
You could take this off. This doesn't have to be here. Okay.
Maybe
And
that's a
Just
design.
you plug the eyepiece right in here, and you do it
Just
that way.
untape it.
This is
Yeah.
not necessary.
Yeah. But
All
it
right.
looks like it's been well used, it's definitely
Oh, I don't know.
What
Maybe
makes you say that?
well, because
he may have
the way
clubbed
the look
something
of
with it.
the tape, or at least he's had to replace the tape over time because you see how it's like degraded and he's replaced it. It looks like
I
he
think this
started
is
with some
more.
black
You
electrical
make it
tape.
sound like this happened every time, but I think this is probably was applied the one time that it got used. The reason you see it is first of all, it's yellowed because it was made a long time ago and probably
Okay,
was outside with a roll of tape, and you have to tape it together so it doesn't fall and
I
move around.
got you. Well, it
Yeah.
almost looks like he used some like Scotch tape, black electrical
Yeah, you're
tape,
right. That's
and
very
masking
observant.
tape.
Very observant. He did. He obviously used
He's
whatever
got
he had
3
available
different
that night.
types of tape on there.
And as you can see on the
He's good.
draw tube, these are all marks, so it's rubbing against something. So as he's trying to achieve focus, that tape is rubbing off. That's what you have.
But at least he tried 3 different types of tape to see what would work on his prototype.
Oh,
You
yeah,
can
he's
see
just got
the
a friction barrier there.
yeah, you can
He's
see
just
the
using
scratches
friction
there.
from
So
the
yeah,
tape
it's
to
rubbing against this part here.
Once again,
Whatever
I'm
it
giving
is.
it a vote for Hall of Fame. I am, because I just love the fact that he's trying to create something out of nothing.
I wonder if
Nothing.
the Scotch
Nothing.
tape, maybe he felt if he covered it with like plastic tape, the masking tape wouldn't wear as much. Maybe he thought that that would reduce the abrasion. I don't know.
Did he say what the tube material is?
Yeah, I think it's some type of PVC.
It
This,
looks like
I
rubber.
always say in pictures, I should have copied the text for this. I don't think I did. I'd love to read the write-up.
It's a fun little scope though.
Well, it's a great example. It's super fun.
Bravo
and
for
look at.
first effort, if it was his first effort.
I think with that, I'm going to allow that image to take us out. We're done. If you feel like stopping by for the after party, we'll do that there. Nothing next week. The following week, I think we've got something, and then we've got the Orion Star Party the
It was a
13th.
nice show.
Right?
Thank you, people. I have to go cook dinner.
Very good.
Yeah. Thanks so much for the Sunny Sun report and showing up, and for all of your contributions, Hank and Sonali and Mark and Keith and Jenny Skedaddle and all the rest of you who are watching the replay from home or from wherever you are. It's Tuesdays at 8, and